In this video, I will be explaining and demonstrating my Smart Night Light program. So, as you can see here, I initialized my CDS on GPIO 6 and my PWM LED on the GPIO 23 pin. Next, I made this while loop here, which will allow the program to infinitely repeat as many times as it would like. Then inside this loop, I have my light value, which takes the CDS value, rounds it to 2 decimal points, and multiplies it by 100. So essentially, we'll round it and turn it into a whole number from that decimal. So say it was 0.95566724 something like that. It would round it to 0.95 and multiply by 100, making it 95. Then using that value, we will check, is that light value less than 5? And the reason I'm doing this is that the GPIO CDS slider does not go fully to 0. It only goes up to 5 as the minimum. So to counteract 5 being the minimum, as that could cause problems with the dashboard and calculations, I just decided if it's below 5, that you would set it straight to 0 so that you can have that 0 value. And because of this, in this else statement here, we must adjust all of the values by 5. So subtract 5 from any value so that it's all, appropriately set up. So the numbers will all be the same as they were before, just minus 5. And then here we have this if statement here, which checks our light value, and it will see if the light value for the maximum is above 91, as normally in 90% of the test runs, you can see that 90 will be the most the most appearing maximum 90% of the time. But sometimes it will spike up to this 91, which can cause problems with the PWM LED, as it can only go up to 100%, and having it be 91 divided by 90 is over 100%, which will cause it to crash. So having it so that we'll set it back to 90 is the way you can get around having that crash error. Next, we have this inverter, or what I call it, inverter for the light value, which basically just takes the value, subtracts the maximum, so 90, and depending on what the value is, say the value is 90 and you subtract 90, you're going to reach 0, and then say it was 0 and you subtract 90, then you reach negative 90. So you do the absolute value of that 90, negative 90, and you would get the new maximum, which would be fully off would technically now be fully on, and vice versa. Fully on will now be fully off, which matches the description of what we have to do for the assignment, which is have the light turn all the way on if the CDS detects no light, which, is the opposite of what the CDS normally does. It usually checks how much light there is and then raises the PWM value up depending on how much light there is. So this basically, instead of checking how high that light value is, it's checking how little that light value is. And here we have our PWM LED 23.value, which basically is what I was talking about. It takes that light value and divides it by 90 so that we can get how much of the light is on and how much of the light is off. So we can see, say we put 45 divided by 90 is 50%, so we'd have a 50% on here, and then we'd see that the light is 50% bright. Next we have this AIO.send, where we send the light value as a whole number, as this bit of code right here, the light value divided by 90, will turn it into a decimal again. So we'll turn that decimal back into a whole value and send it to the gauge to display to the user as a whole number. And then finally we have this time.sleep here, because as we have a AIO.send here, we must have a limit to prevent timeouts, because timeouts for Adafruit is after 30 data points in a minute. So if we don't have that time.sleep of 2 there, then we'll exceed that 30 data points a minute, and we will cause a timeout from the service. So now that we've looked at the code, time to go to the demonstration portion. As you can see here, we have our night light here with our gauge. Currently it's on 33. And if we wanted to, we could go all the way up, which technically with our code they have right now with the inverter, it would technically be 100% off. So as you can see here, 0 on, and the light's fully off. And we can spread it all the way up, which technically would be there's no light, it's 100% off technically. But with that inverter, it would now be 100% on. As you can see, the light's on, and so is our gauge saying it's 100% on. And then we can put it somewhere in between and get somewhere around 50% on, as you can see here, 42%, close enough. You can see that the light is about 40% on, and the dashboard displays that to the user. We also have this little notice to the user telling them that there's a 2 seconds delay between changing the CDS and the LED light color or light intensity and the gauge being updated because of that time.sleep to prevent timeouts. And that's all there is to it. We can adjust it down to 25 or go up to 76. And that's it for this demonstration.